All right, so Sam has 300 feet of fencing to build a pen for his chickens. He would like to build the largest fence possible. Draw a picture of this situation. So it's time to bust out your best artistic skills. I'm going to draw this pen that I'm trying to build. I know that my pen is going to use 300 feet of fencing because that's what I've got. And so there is my pen. And there's a chicken in the pen. Perfect. All right. So I'm going to put an X and a Y here. We're going to label we're going to call the width the X value, and we'll call the length the Y value. It really doesn't matter which one you call the length or the width. These are interchangeable. It says now write an equation for the perimeter of the field. Solve the equation for the length. So perimeter is equal to, well, we got a Y over here and an X over here. Perimeter is the measure on the outside. So take a look how many X's we have. I think we have 2 X's. And then we would add, we also have 2 Y's. Now the perimeter of the field is limited by the amount of fence that I have. How much fence do I have here? It tells me I have 300 feet of fencing. So I get 300 is equal to 2x plus 2y. Now we're going to want to solve that. So I'm going to recopy this. Let me fix this. So this is going to be 300 is equal to 2x plus 2y. I'm going to try to solve for y. So I'm going to subtract 2x from both sides. I can't put these things together, so I get negative 2x plus 300 is equal to 2y. Now I'm going to divide everything by 2 here. So that's going to give me my formula for the perimeter in terms of the width is going to be y is equal to negative x plus 150. So that is my formula for the perimeter in terms of the width. Now it says write an equation for the area of the field. Write this as a function in terms of the width. So we know that the area is equal to the length times the width, right? That's our formula for area of a rectangle. Now, we know the length. We know that the length is y, and we know that the width is x. Now I just did a little work here though. I solved for y. What did I find that y was equal to? Y was equal to negative x plus 150. So what I'm going to do now is we're going to substitute in there for y because we don't want 2 letters here. We just want 1. So I'm going to put negative x plus 150 and then we're going to distribute the x in here. So my final formula or function, now I'm going to write this in function notation because x is the width. So it's the area in terms of the width is equal to negative x times x is negative x squared. And then 150 times x is a positive 150x. And there is my function for the area of this pen in terms of the width. It says, what is the function graphed? Let's go to our graphing calculator or Desmos and let's put that graph in. All right, so I take a look. This is the graph, negative x squared plus 150x. We can see that our domain is restricted between 0 and 150. The reason for that is I can't have this be any larger than 150 because 150 plus 150 is 300 and that's the amount of fencing that I have. It says what function was graphed. What type of graph? This is not the greatest question. What is this graph? What is the parent function? The parent function is a parabola, right? And that is a parabola that is shifted to the right, shifted up, and then reflected over the x-axis. You can see it because it's giving us that frowny face. So what function is graphed? It's a parabola. Find the dimensions that will maximize the area, then find the maximum area. So now what we're looking for is we're trying to find that maximum area right here. We know that that's the vertex of this parabola. There it is, 75, 5625. Now I want to do this algebraically though. I know I should be getting an x value of 75. This is a good thing to use as a reference to make sure you have the right answer, but we're going to need to do this algebraically a lot of times. So again, we're going to rely on that vertex formula. So we are going to use the vertex formula, which you remember the x value is equal to negative b over 2a. And then, so let's start by just finding that x value. So x is going to be, let's think about what a and b are here. Well, the coefficient in front of x is our a value, so a is equal to negative 1, and then the b value is going to be on the x term, so this is b right here. So it is going to be negative 150 over 2 times negative 1, which is going to give us negative 150 over negative 2. Negative 150 divided by negative 2 is 75. Now think about what we found. We found x. What is x? X is the width. So that's going to be our width. Is that all it asked for? Be careful here. It says find the dimensions. And to find the dimensions, I need a width and I need a length. Remember what the length is. Length is y. And do we have an equation that can help us solve for length? Yeah, it's this one right here. This is the equation that helps us solve for y. So we just plug that in there. So y is equal to negative x, so negative 75, plus 150 is equal to 75 would be the length. So the dimensions that would maximize the area of this one is 75 by 75. So that would actually just be a square. Remember, a square is a rectangle. Now, how do we find the area? There's actually two ways we could go about this. We could plug 75 right here into the area function. So we can do a of 75, which is equal to negative 75 squared plus 150 times 75. And when I work that out, I get 5625 feet squared. We want to put a unit on this. Actually, we should probably put a unit on everything. So make that 75 feet, 75 feet. Let's make that feet 2. Let's make that feet 2. If you're thinking to yourself, is he going to take off points if I don't put a unit at the end? The answer is yes, you probably should be safe. So that's one way. The other is just find the area of this. It's 75 times 75. So the area ends up being 75 times 75, which is also 5625 feet squared. Now, one last thing I just want to show you. If we go back to our Desmos graph, we can see that with a width of 75, the y value is our maximum area of 5625, which is exactly what we got.